Sound. I mean, it is literally everywhere. It's the first thing we hear in the morning. It's the sound of a friend's voice. It's the music we love. It's so fundamental to our lives, right? But have you ever really stopped to think about what sound is? How does it even start? And what kind of incredible journey does it take to get from, say, a guitar string all the way to your brain? Well, that's what we're going to find out. So, take a look at these instruments. You've got a sitar, some tablas, a harmonium. They all look and sound totally different. They create completely different feelings. But what's the one thing they all have in common? What's the one secret ingredient they all use to make music? So that brings us to the two big questions for today. First, what in the world is sound at its most basic level? And second, how on earth does it travel from its source, fly across a room, and somehow get processed inside our heads? Let's follow that journey together, step by step. Okay, our journey starts right at the source. And believe it or not, every single sound you have ever heard, from the quietest whisper to a massive thunderclap, it all starts with the exact same physical thing. Now, what I love about this is that it gives us a visual clue. If you take a metal dish full of water and just gently tap the side, you hear a sound, obviously. But you also see something happen, right? You see these little ripples, these waves, spreading out. Well, that is not a coincidence. The sound and the waves are completely connected. And that gets us right to the heart of it. Sound is born from vibration. A vibration is just a fancy way of saying a to and fro or back and forth motion. So when that dish got hit, it vibrated. And that's what made the waves in the water and the sound in the air. The bottom line is this: if you can hear it, something, somewhere, is vibrating. And you can see just how universal that is right here. You pluck a rubber band, and you can literally see it shaking back and forth as it makes that twanging sound. Or you clash a pair of cymbals, and you can feel that buzzing vibration run right up your arms. The objects are totally different, but the physics? It's exactly the same. Vibration is the key. Okay, so objects vibrate. That makes sense. But what about us? We don't have strings to pluck or skins to hit, so how do we make some of the most complex sounds on the planet? Our own voices. Well, it turns out we have our own built-in instrument. It's called the voice box, or larynx, and stretched right across it are these two little bands of muscle called vocal cords. So when we push air up from our lungs, it makes them vibrate. And that vibration, that's the raw material of your voice. So why do our voices sound so different from person to person? A huge reason is just the size of our vocal cords. As you can see here, men's vocal cords are usually longer than women's, and kids are the shortest of all. Think of it just like a guitar string, you know? A thicker, longer string makes a lower note than a thin, short one. It's the same idea. Longer vocal cords vibrate slower, and that produces a lower-pitched voice. All right, so we've cracked the code on how sound gets created, but that's only half the story. A vibration that just stays in one place is pretty useless. It has to travel. So how does it get from the source to the listener? Okay, check out this simple but super clever experiment. You put a ringing cell phone inside a glass container. Then you start sucking the air out of that glass, and something wild happens. The ring gets quieter and quieter and quieter, even though the phone is still vibrating like crazy inside. This proves something huge about sound. And what that little experiment shows us is a fundamental rule. Sound cannot travel through nothing. It can't go through a vacuum. Unlike light, it absolutely needs something to travel through, a substance, what scientists call a medium. This is exactly why outer space is totally, completely silent. There's no air for the sound waves to travel on. Luckily for us, here on Earth, sound has plenty of highways to choose from. It travels through gases, right? Like the air that's carrying my voice to you right now. It travels through liquids. That's how whales and dolphins can talk to each other across miles of ocean. And it even travels through solids. Remember those old toy telephones made with a cup and a string? The sound zips right down the string. So, we've created the vibration, we've sent it on a journey through a medium. Now it's time for the final stop, arriving at its destination, the human ear, and being translated into something our brain can actually understand. The whole process kicks off with the part of your ear you can actually see. Its unique funnel shape isn't just for looks. It's perfectly designed to catch all those incoming sound vibrations and channel them down a little tunnel towards a very, very important piece of equipment. And at the end of that tunnel is the eardrum. Our source material puts it perfectly. It's like a stretched rubber sheet.
So when the sound vibrations that were traveling through the air finally hit this tiny membrane, they make it vibrate in perfect sync with the original sound.
And from there, it's like a super fast chain reaction. The eardrum vibrates, it passes those vibrations to tiny bones in the inner ear. The inner ear then does this amazing trick where it converts those physical shakes into electrical signals. And finally, boom, those signals shoot up to the brain, which does the miraculous final job of saying, ah, that's music, or hey, someone's at the door.
Okay, so we have now completed the entire journey, from a simple vibration all the way to a thought in our brain. Pretty incredible. But of course, we all know that sounds aren't created equal. Some are loud, some are quiet, some are super high, some are really low. So let's take a look at what gives sound its unique character.
Turns out it all comes down to just two things: how big the vibration is and how fast it is. Loudness is all about amplitude, which is really just a sciencey word for the size of the vibration. You hit a drum harder, you get a bigger vibration, and that means a louder sound. Simple. Pitch, on the other hand, is all about frequency, or how fast that vibration is moving back and forth. We measure that loudness in units called decibels, and this table gives you a really good feel for it. Your normal breathing is super quiet, around 10 decibels. A conversation like this one is about 60. But look at this. Once you get above 80 decibels, the level of an average factory, sound actually starts to become physically painful to our ears. And now for pitch. When something vibrates really fast, it creates these sound waves that are packed super tightly together. Our brain interprets that pattern as a high-pitched or shrill sound. Think of a bird chirping or a whistle. On the flip side, a slow vibration, like a big bass drum, creates waves that are really spread out, and our brain hears that as a deep, low-pitched sound. Now, sound is obviously essential, but what happens when there's just too much of it? When we're surrounded by excessive or unwanted sound, it stops being just sound. It becomes noise pollution. And this isn't just about being annoying. It's a genuine health issue. I mean, being exposed to loud noise all the time can cause a whole host of serious problems. It can mess up our sleep, it can lead to high blood pressure, even anxiety. And in the worst cases, it can cause temporary or even permanent damage to our hearing. This is why protecting our ears is so important. And that really brings us to our final thought for today. Sound is this beautiful, vital part of our world, but it's also a really powerful force that we need to be mindful of. So the question I want to leave you with is this. Since we can't just escape sound, it's woven into our lives, what can we do in our own lives and in our communities to help manage noise and create a healthier, more pleasant world of sound for everyone?